Hi, my name is Ray. I'm with MEMETech, and I wanted to make a quick video on a part or tool block that I had to make from a pop shop. The drawings and models will be available soon on my Patreon for free. Well, first the models, then the drawing. It's going to take me a while to make the drawing. But yeah, I'll try to have everything up as soon as possible after I drop the video, but I don't know how long it'll be. This tool block is basically for a HAAS SL40 CNC lathe. It is a static tool block. The one shown here is a 1.25 inch diameter bore. That is to fit a Kyocera insert drill that cuts a 2-inch diameter hole around 4-inch depth. I think they're called index drills, but I call them insert drills. But anyways, and I think static means it doesn't move or non-rotating. I think I might be wrong though. But let me show it real quick. The drill that we use for this. It is right here, the DRZ, 2-inch diameter by 1 1/4 shank diameter, and it goes 4-inch depth, maybe a little bit more, but that's about it. It's a Kyocera, and I believe we got the grade for PR 1535, or I don't even know what they're called. Let me see. I don't even know if they're gonna have them right here. Oh yeah, I'm not gonna look for it. That's too much of a bitch. But yeah, we were trying to go for a stainless type of thing. I'll go over that in a bit, what we were doing towards the end, and show a picture of the holder as well. Anyways, the reason I had to make one of these wasn't because we didn't have any. We have a couple of them. It was because we needed a blank. Basically, I guess we need something like this. Oh, whoops. Except, yeah, we needed something like this. Wait, what the fuck? I don't know why I did that, to be honest. What the heck? Except, okay. Alright, well, yeah, we needed it to look like this. Well, this is basically what I made, or whatever, minus the radiuses and all that stuff. Well, plus the radiuses. This is bare bones or whatever, because I couldn't find the original. But yeah, this is basically what I made, and it would be drilled inside the machine, and I'll get to that in a bit. And we needed it. The reason we needed a blank was because the HAAS SL40 CNC lathe that we have here at my pop shops, the turret is not aligned with the chuck. And in order to drill, or at least, drill sort of more efficiently, you need to have the turret aligned with the chuck. If not, the drill, will be off center. And also, this job was for a duplex stainless. It was for something that I've never worked with. I've worked with the regular stainlesses, but I didn't, really know what to expect. The only fucking mosquito, dog. The only information I found was that you can cut it, like it's it's cuttable or whatever. But I didn't really find much else. So, in my opinion, I basically had to make sure it was centered because I know some materials allow you to not care so much. Because a while back I drilled some aluminum on that machine, and that was back then when I didn't have this tool block or whatever, and it was a different tool. It was a spade drill. It was a 3-inch spade drill or something. And I mean, it worked. I didn't even check I don't even remember the diameter. I don't know if I checked anyways, because I'm pretty sure I had to machine the inside or whatever. So I didn't really care as long as it, opened it up. But yeah, I'm pretty sure it was off center, and it was off a lot. I think it's off by like 80 thousandths or 100 thousandths. I'm not sure. But like from the center, like, because there's like a button on the HAAS machine that you press F2 to center or something like that. Whenever you're doing the work offsets or the tooling offsets or whatever. But yeah, I think it's off. Like whenever we put a dial indicator, it would be off as much as like 100 thousandths, I believe. I can't really remember though. But I've also heard that some stainlesses can, be unforgiving. Like they can work harden. So yeah, I didn't really want to take any chances in the tool, rubbing down on the inserts and work heat treat on the part. Well, I mean, it might not be a possibility, but anyways, I didn't, want us also to abnormally be changing inserts or wasting inserts on a point, or not just wasting inserts, or maybe the tool just breaks, or there's a point of failure, and I didn't want the misalignment to ever have to come to mind, to be like, oh man, I just wanted to be able to cross off something, like in case it ever failed. It didn't. Everything worked out fine. We're even gonna use it again, but I just in case, like just in case it ever failed, I just wanted that to not be, we could just rule that out. It not be a problem or whatever. But in short, we had to we had to align the turret. We had to make sure, the hole came out aligned or whatever. Or the tool was centered or whatever. And our choice was either align the turret to the chuck or make a blank tool block, like this. And don't get me wrong, the alignment, is well needed, but, the economic state of the world won't really allow us. So, but I mean, we got sort of an estimate. Well, not really. He didn't really give us a price. He just told us, our tech, he just told us it would be like around half a day to a full day's worth of work. So, I mean, it's basically a ballpark, I guess I would say. I don't know, like $1,000 to $3,000 or something like that. I don't know. I could be wrong, but yeah, that's just what he told us. A day or half a day's worth of work, something like that. So, like I said, we decided to go with the more economic choice, and which was choice 2, and it was to make a blank. We theorized that if we made a blank with no pilot hole or nothing, that if we drilled it using the chuck, that would come out straight to the center position of the chuck, no matter how misaligned it is. Of course, there are some variables that could still produce shitty results, but after everything we did, it worked well enough. I mean, I'm not an expert, like I said. So, I mean, it worked economically enough, good, insert wise, sorta. Basically, what we did was bore the jaws to hold 2 sleeves with the same outer diameter. The sleeves differed in inside diameter though. One was a 1-inch bore to hold a collet type holder for a center drill, and the other was a 1 1/4-inch bore, I believe, and I really can't remember, but it held a spade drill that drilled up to, I think it drills up to 1 3/8. And first we drilled, I believe it was 1 1/8 to 1 3/16 with one spade. Then with the other spade, we drilled it. We basically bored it to size, drilled it to size, whatever. I was kind of hoping that it would, make it a little bit oversized, since I was kind of using, honestly, a longer drill than I should have. So I was thinking, Since it was a longer drill, I was like, it's probably gonna open oversized. Something is not gonna be aligned. But to my surprise, it was kind of a bitch putting it in. Like, I guess we did a good job. Like, I guess that's like a telltale of doing a good job. That it went in. It was difficult. Like, I had to fucking rub it down. I had to grab the Kyocera tool, give it a dirty rub down with rotation and fucking sandpaper and shit by hand, because I didn't want to. You don't want to do it with a grinder or some shit. Fuck it up. But yeah, I just took some sandpaper, gave it a some rotational rub down with it, and after that, I had to beat it in. Like, I also fingered the fucking bore a bit, with some sandpaper. Images there, making that phase, just hitting that sandpaper inside the crevices of that bore. So in the end, like I said, I had to beat it in with a plastic hammer, with a plastic mallet. I think it was a orange plastic hammer, or either I used the black one with the rubber. I don't know, something like that. But anyways, like I said, I think that's like a telltale sign that it came out pretty good. The hole came out pretty line, because if something would have been off, I think it would have drilled oversized. Maybe I might be wrong. I'm thinking, but I don't know. It was pretty tight. Like, it was hard to put in. I had to beat it in after, you know what I'm saying, doing all of that. But it was able to go in and everything, and it pretty much looked like this at the end, like that. That's how it looks. I won't lie though, I did fuck up. You'll see various things. Well, not really. It's not some things are not really core critical, but I think one of these things that did fuck up was kind of critical. So I forgot, like, after I drilled it, did the blank and everything, we were waiting for approval for the job. The homie had told us we were gonna get the job, but we were waiting, so we kind of let it just sit there, chill. I had pretty much done everything. I tapped this, tapped that. I tapped everything except these two fucking holes, basically. So once I put it on the machine, once the day of, like, I was like, all right, I'm gonna start drilling it. All right, let me go get the balls, the brass balls to put in here for the coolant. So I went over there, grabbed it, and I'm like, all right, I'm gonna need 2 screws. And then I realized, holy fuck, I don't have the screws. I didn't buy the screws. So it pretty much dawned on me that if I didn't buy the screws, if I didn't think to buy the screws, I probably didn't tap them. And I wish I was wrong about that, but sadly I was right. And I couldn't tap it on the machine once I had it, because that would defeat the whole purpose of fucking drilling it on the machine. If I take it off to tap them, it would misalign the hole again. So I was like, fuck it, you know what I'm saying? Doing it live, you know what I'm saying? Like that dude talking about the brown or whatever, like, you know what I'm saying? Tear that up right now, you know what I'm saying? We just had to do it. But I mean, it worked, because all I had to do was just fiddle with the pressure of the coolant. And we got one of the nozzles to hit where we needed to hit. The other nozzle sort of hit too, yeah. Not as much, but the first nozzle, it hit pretty good. Everything was good. It worked for everything, like, and it did a pretty good amount of pieces. And one cool thing that we noted on the material, we had to buy two different I don't know if it was 2 different companies of material or 2 different vendors, of material. It was the same vendor, like, for us, but I mean the people who make it, maybe it was 2 different creators of the material, because we had bought like some 12 footers and then some 20 footers, and we noticed that the 12 footers came out a little bit softer than the 20 footers, because we had to buy more 20 footers than 12 footers. Well, I mean, we had more 20 footer in material than 12 footer material. And once we got to the 20 footer material, we were changing the inserts a little bit more frequently. So that was interesting to learn, because I had come across that also as well in the past. I was doing some parts that we had to mill out a ton of stainless on, and we had like 30 pieces to do, and it wasn't like something difficult. It was just drilling. It was just milling like flats. That's it. Just going back and forth. The machine would go down on the Z, then it would go up on the Y, then it would go down on the Z, go down on the Y, go down on the Z, go up on the Y. You know what I'm saying? You know what I'm saying? It would go up, you know what I'm saying? Go down on the Z, go down on the Y, go down on the Z, go up on the Y. You know what I'm saying? It was cutting. You know what I'm saying? It was just like simple motion. And we noticed that they had gave us 2 different heat numbers. We didn't buy the material for this. They gave us 2 different heat numbers. And once we got to the different heat number, we noticed that the inserts would only last 1 part, because we were taking off so much material with these milling inserts that we would basically do at the most 3 parts per insert change, side change or whatever. But once we got to this material, we would only be doing one piece, and we had to change the inserts. So yeah, we had dealt with some, and it was also stainless. You know, it was interesting. I was like, oh shit, that's pretty cool. I don't know, it was just something cool, just something I noticed. And another thing that I had to do with this project for this parts, I don't know if I explained it already, but basically just what we're doing is we're drilling 2-inch diameter into some long stainless bars, and we would have to cut them on the machine. We have to drill, then cut. We would drill 3 inches deep, 3 1/8 deep, and we would cut the parts 3 inches in length. And that's all we had to do for the first phase. And that's basically what we made this for, the drill or whatever. But in order to make this, I had to make a boring ring, and that was also pretty cool. I forgot to put pictures of this, like, cause I only have like that one picture that I took like right now of the this thing on the machine. But yeah, I had to make quite a few things in order to get this sort of thing to work. And anyways, yeah, like, I'm not sure if HAAS had these. I don't know if they sell blanks. I know they sell, of course they fucking sell the things, but I don't know if they sell blanks. But yeah, we also didn't want to, you know, wait and for the shipping or anything, because this is also heavy, so who knows how much the shipping would have cost. So we just decided to make it in-house. We have 2 of them. Let me show the picture. Where is it? Okay, I guess I don't have it. Hold on. Where the fuck is it? So there it is. That's the drill. 2-inch diameter by 4-inch from here to here. We got the 1/2-inch threads right here. I think I had almost fucked up this one. You can see there's different radiuses right here. There's a big radius. This is a smaller radius. But anyways, like, everything worked out pretty good. We got the job done. Yeah, that's pretty much it. I took measurements from the ones that we already had. We have a few. They are like a 2.5-inch bore. I don't really remember the other sizes, but we also had sleeves and stuff. Also, I took measurements of this with a dial caliper, just so, you know, we're clear how I, you know, measured it. I didn't use micrometers or anything like that. I just used I believe it wasn't even Mitutoyo. It wasn't even Mitutoyo. It was a fucking it was AccuSize, but it's nice. Like, I like it. Like, I like my AccuSize dial calipers. They're pretty good, especially for the price. I like it. And I don't know, it's different because everyone just gets Mitutoyos or Starrets and stuff, and I don't know. It's nice to get cheap ones that people won't grab, you know. But yeah, and the final thing is just the diameter can be changed. I didn't test the diameter, but like I said, I took measurements with the dial caliper, so it should be good. Because like I said, I bored this on the machine, so this measurement to this sensor, I got it from the parts, but I didn't test it, just so we're 100% clear. I'm pretty sure it's well within, I'd say, 3,000ths position, I think. Probably talking out my ass, but yeah, that's one disclaimer. I didn't, like I said, I bored it inside the machine, so the machine gave me the center. I don't know if this measurement is 100%. It might be 99.999%. You know what I'm saying? And another disclaimer: these holes in the back, these 3 threads, I'm not sure if the measurement is correct on them. I did my best to get these measurements, but I didn't use this. The only thing I used was this, just to plug it up, because if you can see at the bottom, it's they kind of meet or whatever. I just did it just to match it, and I also gave it an MPT thread. I forgot to put the fucking MPT thread right here, but I'll see if I do it later. But anyways, this is supposed to be an MPT thread right here. I might as well do it now. Let me see. 3D model. Where is it? Thread. This. And it's MPT. I don't even know what fucking size it is. Fuck. I'm just gonna put half. I'll check it out later and I'll edit it out before I upload it. Because all I have to do is just check the ID and then just Google the drill size for the MPT threads, and whatever inside diameter this is whatever the drilling diameter should be for the other things, for the tap drill size or whatever. But anyways, thanks for sitting here, hear me blabber and yap about this stuff. This was a little bit more composed, but it's still not that good. I will be trying to get better in the future at content creating, because I'm still kind of sort of all over the place. I'm still not that good at reading, and I'm still not good at keeping up and stuff. But yeah, thank you for watching. Again, if this helped, if you were looking for a HAAS SL40 tool post and this helped, you know, drop a like, comment, you know, let me know if this something is wrong, like if you did it and something's fucked up, you know, like the bore size is not correct or whatever. I mean, not the bore size, the bore position is not correct, you know. Let me know how it turns out if you decide to make one. And yeah, like I said, thanks for watching. Subscribe, follow my Patreon, socials, and like I said, all this stuff that I make is gonna be for free. Anything that I can release to the public will be for free. There are some things that I can't release that you will see on my channel, and or I would probably have to follow up with a lawyer about it. But more than likely, I probably can't release some of the things. But this is something that I can release. I don't mind showing this. I took measurements of what we already had, you know, just in case someone random needs the measurements to SL40 tool post. They have this machine at, you know, their shop, their family shop, their workshop, whatever. But yeah, I've been saying bye for like the last fucking minute. But thank you for watching for the 3rd, 4th time. And later.